Parkinson's disease is a brain disorder that leads to shaking, stiffness, and difficulty with walking, balance, and coordination. Parkinson's symptoms usually begin gradually and get worse over time. Parkinson's disease is caused by a loss of nerve cells in the part of the brain called the substantia nigra. Nerve cells in this part of the brain are responsible for producing a chemical called dopamine. Inside the brain, dopamine plays important roles in executive functions, motor control, motivation, arousal, reinforcement, and reward, as well as lower-level functioning, including lactation, sexual gratification, and nausea. Magnesium is a mineral important to several bodily functions, including nerve cell transmission and neuromuscular coordination. Low levels of this mineral have been reported in motor regions of the brain of Parkinson's patients. Magnesium is also required for the proper functioning of hundreds of enzyme systems in the body. Therefore, its supplementation can produce profound benefits over time. The best form of magnesium is magnesium bisglycinate. In order to assess your dosage, gradually increase until stomach discomfort or diarrhea is noticed. Then reduce until you can find your maximum tolerable dose that doesn't cause any stomach upset. Omega-3 fatty acids protect the brain against Parkinson's disease, according to a study by Université Laval researchers. This study is the first to demonstrate the protective effect of a diet rich in omega-3 fatty acids against Parkinson's. Dietary supplementation with omega-3 fatty acids increases dopamine levels and D2 receptors and also lowers monoamine oxidase B. Common doses of omega-3 range from 3 to 9 grams per day of a molecularly distilled EPA-DHA fish oil blend. Homocysteine is an amino acid produced when protein is broken down. A high homocysteine level, also called hyperhomocystinemia, can contribute to arterial damage and blood clots in your blood vessels. High homocysteine levels usually indicate a deficiency in vitamin B12 or folate. Plasma homocysteine levels may increase in levodopa-treated patients with Parkinson's disease. Vitamin B12 is lower in patients with Parkinson's disease when compared to controls, and low levels have been associated with peripheral neuropathy, cognitive impairment, and more rapid rate of disease progression of Parkinson's disease. It's important to note that a blood test may not pick up a B12 deficiency, as food is now fortified with folate, and this can give a false reading in the B12 blood test. The best oral form of B12 is methylcobalamin. Considering the potential synergistic deleterious effects of homocysteine increase and folate deficiency on the central nervous system, it's postulated that folic acid should also be supplemented to patients affected by Parkinson's disease in order to help normalize the homocysteine levels and the folate levels, therefore potentially avoiding the risk factors that come with it. Trimethylglycine from sugar beet may also help to normalize homocysteine levels. Vitamin B1, thiamine. It plays a beneficial role in Parkinson's disease by inducing dopamine release and improving the symptoms associated with Parkinson's disease. A synthetic form of thiamine called sulbuthiamine may have some benefits here. In animal models, sulbuthiamine has been shown to increase the number of dopamine binding sites, specifically the D1, in the prefrontal cortex of the brain. Vitamin E is an antioxidant believed to help with brain health by reducing oxidative stress. Many studies have shown that vitamin E supplementation can reduce the risk of Parkinson's disease. It would be best to take a mixed tocopherol with a natural form of vitamin E. Previous cross-sectional studies have shown that Parkinson's disease patients have lower serum 25-hydroxy vitamin D levels than the controls. Vitamin D deficiency was associated with increased disease severity and cognitive impairment in prevalent Parkinson's disease patients. You can get a 25-hydroxy vitamin D blood test to determine your levels and then supplement accordingly. Vitamin K2 works synergistically with vitamin D3 and it may help in Parkinson's disease. Vitamin K2 plays a role in energy production of defective mitochondria. Because defective mitochondria is also found in Parkinson's disease patients, vitamin K2 potentially offers hope for a new treatment. The maximum dose that your body can absorb is 300 micrograms per day, so supplementing with more than this would not be necessary. Glutathione, known as the master antioxidant in the body. In people with Parkinson's disease, glutathione levels are lower in the brain, specifically in the substantia nigra, the area in which dopamine cells are lost. Also, the levels of reduction in glutathione have been associated with Parkinson's disease severity, which means the less glutathione, the more advanced the Parkinson's disease. Selenium is required for your body to synthesize glutathione. By eating 3 Brazil nuts per day, you can get your recommended daily allowance of selenium. You can also boost glutathione in many ways, such as taking reduced glutathione at up to 1,000 milligrams per day, taking N-acetylcysteine at 500 milligrams 3 times per day, and taking the herb milk thistle. Research has indicated that green tea possesses neuroprotective effects, specifically in Parkinson's disease. It was discovered that green tea polyphenols protect dopamine neurons that increase with the amount consumed. Patients with Parkinson's disease showed a significant decrease in zinc status when compared to controls. There's also a correlation with low vitamin C levels and Parkinson's disease. Therefore, supplementing with vitamin C and zinc may be beneficial. Zinc picolinate or zinc citrate are some of the many available forms of zinc, and a typical dose could be 50 milligrams per day. Vitamin C can be taken intravenously for best results, or orally. The next best form is liposomal vitamin C, then a non-acidic vitamin C, and the worst kind being ascorbic acid due to its digestive discomfort that accompanies it. CDP choline may enrich dopaminergic therapy in Parkinson's disease through multiple mechanisms, including decreased reuptake of dopamine, leading to increased levels at the synaptic cleft. And additionally, CDP choline activates tyrosine hydroxylase and induces increased dopamine production. Brain neurons form synapses throughout the lifespan. This process is initiated by neural depolarization. However, the number of synapses thus formed depends on the brain level of 3 key nutrients: uridine, the omega-3 fatty acid DHA, and choline. Given together, these 3 nutrients accelerate the formation of synaptic membranes, which are the major component of the synapses. You can see my other video on choline supplements for nootropics about the different types of choline available. Uridine. Naturally found in human breast milk, uridine is now made synthetically and can have many benefits to the brain. Dietary uridine 5-monophosphate supplementation increases potassium-evoked dopamine release and promotes neurite outgrowth in aged rats. This could be beneficial for people with Parkinson's disease. In trials, doses have ranged from 1 to 2 grams per day of uridine monophosphate. A common user report is that they have increased verbal fluency after consuming uridine. Hence, it's taken as a nootropic, which is a brain-boosting compound. You can check out my other video on nootropics for more information. Acetyl-L-tyrosine and N-acetyl-L-tyrosine. Because tyrosine helps the body produce the mood-influencing chemical dopamine, and because people who are depressed often have low levels of tyrosine, researchers thought that tyrosine might help treat depression. L-tyrosine is given at 1,000 milligrams per day, divided into two 500 milligrams dose, and when it was given for 7 days, it was found to be safe and well tolerated in Parkinson's disease patients. Although this might not be beneficial on its own, it may help to provide some of the building blocks in order to make some of the other dopaminergic supplements already mentioned in this video work more efficiently and not cause another deficiency in the body. ALCAR and ALA, or acetyl L-carnitine and alpha-lipoic acid. The disruption of neuronal iron homeostasis and oxidative stress are related to the pathogenesis of Parkinson's disease. Alpha-lipoic acid is a naturally occurring enzyme cofactor with antioxidant and iron chelator properties and has many known effects. Alpha-lipoic acid has a neuroprotective effect on Parkinson's disease. Recent experimental studies have shown that administration of alpha-lipoic acid and acetyl L-carnitine can reduce oxidant production and improve mitochondrial function in models of aging, so it may have life-extending possibilities also. Common doses are 500 milligrams per day of acetyl L-carnitine taken twice, and 500 to 600 milligrams of alpha-lipoic acid taken 2 to 3 times per day. Avoid MSG. Monosodium glutamate is added to food to increase addiction by overstimulating the brain. This overstimulation can lead to overexcitation and cause brain cells to become damaged. MSG also altered the dopamine content in adult rats in both the posterior cortex and the striatum, causing a reduction of dopamine of 23% in the posterior cortex and an increase of dopamine of 12% in the striatum. The main problem is that MSG is now hidden in food by using many different names, such as yeast extract. One sure way to avoid MSG is to only eat fresh produce and remove all processed foods from the diet. This obviously has many other health benefits too. Aspartame, the artificial sweetener, has been linked to behavioral and cognitive problems. Possible neurophysiological symptoms include learning problems, headaches, seizures, migraines, irritable mood, anxiety, depression, and insomnia. The consumption of aspartame, unlike dietary protein, can elevate the levels of phenylalanine and aspartic acid in the brain. These compounds can inhibit the synthesis and release of neurotransmitters dopamine, norepinephrine, and serotonin, which are known regulators of neurophysiological activity. Aspartame acts as a chemical stressor by elevating plasma cortisol levels and causing the production of excess free radicals. High cortisol levels and excess free radicals may increase the brain's vulnerability to oxidative stress, which may have adverse effects on neurobehavior and may negatively impact Parkinson's disease patients. Turmeric. Since curcumin, which is turmeric extract, exerts neuroprotective effects on Parkinson's disease models induced by several different environmental factors and genetic factors, results provide additional evidence to demonstrate that treatment with curcumin may be of benefit to Parkinson's disease patients. Doses can range up to 5 grams per day of curcumin, which has poor absorption. This absorption, though, can be increased with black pepper extract, which is known as biopterin, or by consuming the curcumin fried in coconut oil, ghee, or butter, or taken with fish oil capsules. Individuals with Parkinson's usually have low levels of coenzyme Q10. It protects neurons from toxins and encourages energy production in cells. It works synergistically with vitamin E. Dietary sources include fish, organ meats, and whole grains. In trials, doses of 300 to 500 milligrams of CoQ10 per day were needed. CoQ10 also works synergistically with 40 milligrams of PQQ. In a study, participants were followed for between 20 to 22 years, and then their flavonoid intake was compared with rates of Parkinson's disease. Researchers found that the 20% with the highest flavonoid intake were 35% less likely to develop Parkinson's disease than the 20% with the lowest flavonoid intake. When the researchers looked specifically at the flavonoid group known as anthocyanins, which occur primarily in berries, they found that both men and women with the highest intake were 22% less likely to develop Parkinson's disease than those with the lowest intake of berries. Researchers used data from a cancer prevention health survey of dietary and lifestyle habits of 73,000 women and 57,000 men to compare dairy intake with Parkinson's risk. They found that the men who ate the most dairy were 60% more likely to contract Parkinson's disease than men with the lowest intake. Milk accounted for the most of the correlation, rather than more processed products like yogurt and cheese. This data for this study was collected between 1992 and 2001. For people with Parkinson's disease, sleep becomes even more important as the body needs more time to restore and repair itself. The brain changes that are part of Parkinson's disease can also cause sleep difficulty, and some people have problems sleeping even before movement symptoms develop and Parkinson's disease is diagnosed. Melatonin has been used for treating sleep problems, insomnia, and daytime sleepiness in Parkinson's disease patients. Be sure to check out my other video on herbs for helping sleep.